Hey, greetings. So here we go. This is the second part of our linear programming lecture series. And here we look at the graphical solution to the model. So in the last video, we actually went through the formulation of this model. And this is what we came up with. Now we're going to look at solving the model. All right, so here goes. First step. Graph the constraints. Right, so we always start with the constraints. And by graphing them, what we'll be doing is drawing a straight line for each constraint. Right, remember, it's a linear programming model. So linear means straight line graphs. The other thing that we'll do is we're going to set each constraint to equal instead of the traditional less than or equal or greater than or equal. So we're changing them from inequalities to regular equations, equal sign. So here's the first one. 3x plus 4y is equal to 2400. And we want to graph this line. So we start by setting x to 0 to find the y-intercept. And this is just the easiest way to do it. Technically, we can graph the line by finding any 2 points on the line. Right? But the easiest ones are the two extremes, the two intercepts. So set x to 0 and we'll find where it touches the y-axis. So by doing so, 3 times 0 of course is 0. So we're left with 4y is equal to 2400. Divide both sides by 4. We get y is equal to 600. Alright, so that's the y-intercept. So this line touches the y-axis at y equals 600. Then to find the x-intercept, we set y to 0. So 4 times 0 is 0, so we're left with 3x equals 2400. Divide both sides by 3, and we get x equals 800. So now we're going to be drawing a straight line from y equals 600 on the y-axis to x equals 800 on the x-axis. Alright, so that's the first constraint. Second one, 2x plus 1y is equal to 1000. I remember we didn't really have to put 1y, it's really just y. But I'm leaving the 1 for emphasis. So, same principle, we set x to 0 to find the y-intercept. Right, so 2 times 0 leaves us with y equals 1000. And for the x-intercept, we set y equals 0 to find the x-intercept. And 1 times 0 is 0, so we're left with 2x is equal to 1000. Divide both sides by 2, and we get x equals 500. So we'll now be drawing a straight line from y equal 1000 on the y-axis to x equal 500 on the x-axis. Next, we have y equal 450. And this is more straightforward because it means that the value of y is always 450. Right? So at 450 on the y-axis, we're going to be drawing a horizontal line across, since the value of y will always be at the height of 450. Next one, x equal 100. This means the value of x is always 100. So it's going to be a vertical line upwards from x equal 100. So now we're ready. So now that we are ready to do, with step 1, we're labeling our axes. So x was the number of tables, so we put tables on the x-axis, and we put chairs on the y-axis. So that's 1. Next, we establish a scale, and I'll put scale in quotation marks because technically we just want to know how to label, how to number the axes. Right? So we look at the lines that we're to draw. The first line has y equals 600, x equals 800. The second one, y is equal to 1000, x is equal to 500. And the third one, y is just 450. And the last one, x is 100. Alright, so on the x-axis we need to have values for 100, 500, and 800. So we can go up in movements of 100. Alright, and we could have it like that. So 100 right up to 800 and we're covered. Now for the y-axis, we need to have values for 450, 600, and 1000. So we could go up in steps of 100 as well and just know that 450 would be midway between 400 and 500. But in this case, I'm going to go all out and just go up in steps of 50. Right? So now we're ready. So draw the lines. So the first line, we're drawing a line from y equals 600 on the y-axis to x equals 800 on the x-axis. So that's a straight line. I will label the line. 3x plus 4y is equal to 2400. Next, we have a straight line from y equal 1000 on to x equal 500. Draw the line, label it. 2x plus 1y equal 1000. Sounds so funny when I say 1y, but I'm still leaving it there for emphasis. Next, we have a horizontal line at y equal 450. So draw the line, label it. And finally, we have a vertical line at x equal 100. So draw the line and label it. So we have now captured the 4 lines for our constraints. Step 4, identify the feasible region. This is the region that satisfies all of the inequalities. So we're going back to the inequalities now. So the given constraints were, the first one is 3x plus 4y is less than or equal to 2400. So that means that this line, 3x plus 4y, is equal to 2400. The values must fall below this line. So we can shade that area. Well, technically, you're not going to shade as yet because you're going to see that the area won't be as big as this. But with technology, I have the advantage of being able to shade and remove. So the next constraint, 2x plus 1y, that's this line. We say the value should be less than or equal to 1000. So that means that it must also be below this line. 2x plus 1y is equal to 1000. So it must be below both lines. It must be below this line, 3x plus 4y equal to 2400. And it must be below the second line, 2x plus 1y equal to 1000. So we are adjusting the area to just this section here. Right, so it's below both lines. Thirdly, we have, it should be less than y equal 450. So that's y equal 450. I was saying it should also be below this line. So this section above the line is no longer feasible. So remove that section. We're left with this area. And then last constraint is x is greater than or equal to 100. So it should be greater than, that means above, the x equal 100 line. So this is it. I will now have our feasible region. Right, the region that satisfies all constraints. Now, you might wonder why we didn't graph non-negativity. X is greater than or, both x and y greater than or equal to 0. Now, the graph takes care of that, because if you know we didn't show any negative sections for this graph. We're only showing x greater than or equal to 0 and y greater than or equal to 0. Alright, so let's keep going. So now we want to label our corner points. Now, this method, the graphical method, indicates that the solution, right, the solution to maximize the results for this business lies at one of these corners. So look at the shaded area, I will just look at each corner, just like the corners of a room. And we're going to label. It doesn't matter which order you label them in, as long as you're consistent. Right, so just be consistent. So I'm going to start here, A, B, C, D, and E. Alright, so these are our corner points. 6, we need to now find the coordinates of these corner points. So A, B, C, D, we need to know the x coordinate, the y coordinate for each point. Right? I remember, the x normally goes before the y. So x, comma, y in the brackets. So my thing is always to start with the easy ones, because these don't require the calculation. So if you look at A, right, we can see clearly that it's at y equal 450, x equal 100. So A is 100, 450. X is 100, y is 450. B is a little bit more technical, because we know y is 450, but we'll have to use this equation to solve for x. So I'm gonna, this one more technical because it's the intersection of two lines, right? And we will need to do simultaneous equations to solve for C. But at D, we can see that it's on the x-axis, so we know that y is 0 and D is equal to 500. So x is equal to 500. So for D, x is 500, y is 0. And for E, also on the x-axis, so x is 100 and y is 0. So for these three, we didn't need to do any calculations. I could just write them down. The next easiest one is B. Because we know one coordinate, we just need to solve for the other. Oh, and don't try to just estimate them based on the axes. Right? Actually solve for them. So here goes. So at B, y is equal to 450 intersects with 3x plus 4y is equal to 2400. So we know that y is equal to 450. So we're going to use substitution. In other words, we're going to substitute y equal to 450 into the equation 3x plus 4y is equal to 2400. Alright, so 3x plus 4y is equal to 2400. We do our substitution. Y is equal to 450. 4 times 450, that's 1800. So 3x plus 1800 is equal to 2400. Subtract 1800 from both sides. Right, we get 3x is equal to 2400 minus 1800, which gives us 3x equals 600. Then divide both sides by 3, and we get x is equal to 200. Right, so we have that. So we now know that for B, the coordinates are x equal 200, y equal 450. All right, so only one to go. All right, the last one is C. And C, you'll always have the case where you have at least one way you have to do simultaneous equations. So at C, we have the intersection of 2x plus 1y equal 1000 and 3x plus 4y is equal to 2400. So I use elimination. So for my elimination method, I just want to identify the first number in the first equation and highlight the first number in the second equation. So both coefficients of x, because we're going to eliminate x. Right? So the method is simply take that first number in equation 2, which is a 3, and use it to multiply all of equation 1. Now, why do we have to multiply everything? Because the rule of what we're dealing with is with algebra. The rule is anything you do to one section of the equation, you have to do it to all of the equation. Right? So that leaves the equation intact. So we're going to take 3 and use it to multiply everything in equation 1. Similarly, so let's do that. So 3 times 2x, that's 6x, plus 3 times y, 1y, that's 3y, equal 3 times 1000, which is 3000. So we have done that. Next, we take that first number in equation 1, that 2, and use it to multiply all of equation 2. So we're going to say 2 times 3x is 6x, 2 times 4y, so we're going to get plus 8y, equals 2 times 2400, that's going to be equal 4800. Alright, so once we have that, we are ready to do our elimination. So we're just taking the difference between the two equations. So 6x, same in both equations. Right? Difference between 8 and 3, that's 5y. Difference between 4800 and 3000, that's 1800. So we now have 5y is equal to 1800, and we have eliminated x. So now we want to find y, and we're going to divide both sides of the equation by 5. And we're going to get y is equal to 360. So now that we know y, we can use substitution by substituting y equals 360 in any of the original equations. And we can use that to find x. So let's go. So we know that y is equal to 360. Using substitution, right, we're going to use the first one. So we have 2x plus y equal 1,000. So we're now going to say 2x plus 1 times 360 is 1,000. Subtract 360 from both sides. We get 2x equal 1,000 minus 360, giving us 2x equal 640. Divide both sides by 2, we get x equals 320. So we now know that x is equal to 320 and y is equal to 360. So we now have all 5 corner points, the coordinates of all 5 corner points. So here they are. All right, so that's step 6. Find the coordinates of the corner points. Now, once we have the coordinates, we can move to the next level. All right, we're going to calculate the profit at each of these corner points. Remember, the equation is the objective function says maximize the profit, and we calculate profit as 7 times the value of x plus 5 times the value of y. And remember that x represents the number of tables, while y represents the number of chairs. So here goes. For the first one, we have 7 times 100 plus 5 times 450. All right, that works out to 2,950. So that's A. That's the profit at corner point A. At B, we have 7 times 200. Right, x is 200, so 7 times 200 plus 5 times 450. That works out to 3,650. So the profit at corner point B is 3,650. At corner point C, we have 7 times 320 plus 5 times 360, which works out to $4,040. So the profit at corner point C, $4,040. At point D, we have 7 times 500 plus 5 times 0. That works out to 3,500 at corner point D. And lastly, at corner point E, it is 7 times 100 plus 5 times 0, which is $700. So this would be the profit at each point. So if we sell 7 tables and 5 chairs, right? Well, X represents tables, Y represents chairs. So if we sell, not 7, if we sell 100 tables and 450 chairs, our profit will be 2,950. If we sell 200 tables and 450 chairs, our profit will be 3,650. If we sell 320 tables and 360 chairs, our profit will be $4,040. If we sell 500 tables and no chairs, the profit will be $3,500. And if we sell 100 tables and no chairs, the profit will be $700. So that's what we just calculated. So the final step is just to know the solution, right? Our aim is to maximize profit. So our solution is the corner point that gives you the highest profit. And it's clear that corner point C with a profit of 4,040 is the highest one. So our solution is corner point C, which says we should make 320 tables and 360 chairs. All right, so that's it. That's graphical solution. Thank you for watching. Please subscribe, please like, right, and provide some comments. Give us some feedback. Let us know how you're being helped or not by the material, what we can do to make it better for you, because the aim is to provide value. So please give some feedback and subscribe for more content. All right, blessings, and we'll be in touch.